This assessment asks us to calculate the KEQ value for this acid-base reaction, predict which side of the equilibrium is favored, and explain why. Our equation for the KEQ value for an acid-base reaction is 10 to the pKa of the acid on the product side minus the pKa of the acid on the reagent side. That means we need to know which molecule is the acid on each side of the equilibrium and what its approximate pKa value is. The acid on the reagent side is this carboxylic acid with a pKa of approximately 5. And the acid on the product side is the alcohol with a pKa of approximately 16. We can plug these values into our equation to calculate KEQ. KEQ then is 10 to the product pKa, 16, minus the reagent pKa, 5. That means KEQ is 10 to the 11th. 10 to the 11th is greater than 1. That means the product side of the equilibrium is favored. But why? The product side of the equilibrium is favored because the products have the weaker acid and the weaker base. The O- that is resonance stabilized is more stable than the O- that is not resonance stabilized. That makes this the weaker base. A higher pKa value means that the alcohol is a weaker acid than the carboxylic acid. Because the product side has the more stable acid and base, that side of the equilibrium is favored with a KEQ value of 10 to the 11th.